The talk is about the temporal dynamics of tinnitus and the use of apps in the real world. And I want to first quickly start about where this all started. And this started by some patients that reported to me that whenever that tinnitus fluctuates, and that there are some moments where tinnitus is terribly loud and some other moments where the tinnitus is soft and they don't really care about it. And then I realized, well, to be honest, these fluctuations of the tinnitus, these temporal dynamics, that is not covered in the theoretical models about tinnitus. And in all our research, we don't really talk so much about these temporal dynamics, but I think it's important to understand these fluctuations. And it was 2013 where I met a person who's now a very good friend, Rüdiger Prüss. He's an informatic engineer, and we talked about tinnitus, and we talked about my work and about his work, and then we realized, well, these temporal fluctuations, that's something that you can really measure with apps, and he knows how to develop the apps, and I know how to design studies in the tinnitus field. So that's how this all started, and we did several studies together, and since 2013 now, many things have evolved here in this field, and that's something that I want to share here today with you. We want to talk about how to measure tinnitus fluctuations, talk about what do you know so far, what are maybe the consequences for the clinical studies, and a little bit also some ideas for the future about digital profiling. But first of all, I have to say that, of course, we were not the first people to talk about the tinnitus fluctuations and how to measure it. I recently discovered that even 1988, there was already the idea by Gerhard Göbel to come up with a tinnitus diary that was an analog scale, an analog version also of the tinnitus diary, where people had to make some crosses here on the visual analog scale. How loud is a tinnitus, and what's the current distress, and what's the emotions, and so on. Since then, of course, many things have developed, and we have more technological tools, and now it's electronic devices to capture the tinnitus fluctuations and to measure the tinnitus in different states and different moments. There are several advantages that come with the electronic devices. First of all, we can send electronic reminders and really remind the participants to fill out the questionnaire now. And the second advantage is, of course, then it's all already stored in a database, and we don't have to look at the papers and type the numbers into an Excel file and for further analysis. It's all already stored in the database, and that gives us the opportunity to do high quality data analysis here, and really record also data from many different subjects all over the world. You see here some examples of electronic devices that could be used for measuring tinnitus in the real world. The first was Jim Henry, 2012. He had a publication where they used some palm devices. Then Wilson, they used smartphones, so that they were sending out some short messages with a link, and then people could click on the link, and then a web page opened where they were asked about the tinnitus. And then we had here also some studies with tracheotinnitus, and there's some newer versions here that Milena Engelke has published this year also, and that's part of the Unity project, where later you will hear much more about the Unity project. One important thing here that I want to mention is that when you're measuring the tinnitus on a visual analog scale, no matter if you do it with paper or with on the smartphone, it's really important for these visual analog scale that you don't have presettings. You should really try to avoid these presettings, because they can influence the answers of the patients. When the presetting, let's say the slider is at the beginning on the left side, then you can influence the decision of the participant, or if it's in the middle or on the right hand side. something that we call the anchor effect in the psychology. In a smartphone also you can avoid this by just not having a slider here. You have to touch on the line, and then the slider appears, and that's where you can put then your measurement. So when you look at all these studies that have been done, I have here some screenshots and some figures from different participants in the different studies. These are all single participants that you see. And what you can see here is that there are some subjects where tinnitus fluctuates a lot, and also there are some subjects where there's not much fluctuation. In our studies on the right-hand side, you see that it's mainly it was kind of ceiling effects here when the fluctuation was low, but in other studies and in other subjects, you see that it's not only about ceiling effects. There can be patients where fluctuations is low, and in some others it's very high. And the question now is, of course, what are the reasons? I mean, we can see that there are fluctuations. So yes, tinnitus is fluctuating, but that doesn't help us a lot yet to understand the tinnitus better. And I want to look here at different situations. The advantage of the app is that you can really measure during the real life situation in specific situations, and the patients fill it out while they're doing their normal life, and that gives us the advantage that we can record in these moments, and the ecological validity is very high. So I wanted to talk about the stress, the moments where people experience stressful life situations, and this is something that was published 2016 already. So what you see here is we ask for tinnitus loudness, we ask for tinnitus distress, and also we ask for the stress level in the app. And you can see here a structural equation model, and there you see that tinnitus loudness, of course, influences the tinnitus distress. Very strong interaction. That's not a surprise. But also what you see is that tinnitus loudness influences the stress level, the individual stress level. Here it's an estimate of 0.328. That means that when tinnitus loudness is high, that increases the stress level by 0.328 standard deviations. And this high stress level then also has an influence on the tinnitus distress, which is highly significant. So the stress can be understood here as a mediator here in this model. With more stress, the tinnitus distress increases also. I have here on the right-hand side, I have the picture of the roller coaster. Maybe that helps you to remember this. So basically what you can imagine is you have the wagons here on this roller coaster, the tinnitus loudness, the distress and the stress, and they're all running together through this roller coaster when they're all going together up and they're all going together down and left and right. So they're moving together kind of. And this is also the case for another moment and another variable that we measured, which are the emotions. Whenever people have positive emotions, then their tinnitus is better. When they have negative emotions, then this also influences the tinnitus distress to be more negative in numbers. That means that the tinnitus distress goes up. So with emotions, you can measure basically arousal and the valence. Valence means positive emotions or negative emotions. In our data models, we coded negative emotions with negative numbers, and that's why you see here negative estimates. Basically, that means tinnitus loudness leads to more negative emotions, and more negative emotions lead to more distress. That's how to interpret these numbers here. And important here is also that when you look at the estimates, it's about the same amount of influence, the same size of influence like the stress. So we are all not surprised about the influence of stress on the tinnitus distress, but here I want to emphasize that also the emotions are very important, and maybe emotions are something that we can easily also manipulate, can be maybe used for the therapeutic options here. So in our picture with a roller coaster, maybe we now have 4 wagons here: the tinnitus loudness, the distress, the emotions, and the stress level, and they're all moving together in this roller coaster. Another influencing factor that we looked at was the time of the day. Was it early morning, or was it more during the day or late at night? And here the summary is that the early mornings are terrible. We described it in this paper by so the morning roar. I think that was the idea of Josef Rauschecker to describe it like the roar of the lion in the morning. What we see is that really during a late night and early mornings, tinnitus is perceived louder. What you see for the tinnitus loudness and for the distress in the figure, and then later during the day, tinnitus goes down. Here I used the giant wheel, again in the amusement park, the giant wheel that turns very slowly, 1 cycle a day. In the morning, tinnitus is up, and during the day it goes down, and then in the next morning we are up again here at a very higher tinnitus loudness and higher tinnitus distress. There's another factor that we can look at when it comes to timing, which is the day of the week. And here what we did is we looked at different weekdays. Oh, sorry, and here this is still German: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And Saturdays are the best days here for the tinnitus. There again, like in the giant wheel, but now really, really slowly, 1 cycle in a week. So we have the highest points on Tuesday, Wednesdays, and Thursdays, and when it goes towards the weekend, then the cycle goes down, and Saturdays are the best days with the lowest tinnitus distress and lowest tinnitus loudness, and then towards Sunday and Monday it goes up again to the peak. So these are, as a reminder, we have the stress, we have the emotions, the roller coaster picture, and the early morning and the weekends in this giant wheel picture that goes up and down on a cycle. Then one thing that happened, we all know, Corona pandemic hit us very strongly, and there were people sitting at home or being in a lockdown state, and that has, of course, an influence on the perception of the situations, on the stress levels, and on many other things. And we were interested in how they perceive the Corona pandemic, and also what it has. What's the influence on the tinnitus? It was not an app study, it was an online study where we're sending out questionnaires to the tinnitus patients that were previously in our clinic. There have been 2018, there has been a measurement where we assessed the tinnitus questionnaires on a large amount of patients, and then we had the opportunity to contact these people again during the pandemic. And what you see here is that on average, there's no dramatic change, not on the THI and also not on the mini TQ change, TQ score, but you see here in the left-hand figures a large variability. People were feeling better, the tinnitus was better during the pandemic, or for some people, the tinnitus was worse. And when you look at the variables, like how they perceive the pandemic, and if this correlates with a tinnitus change, then we see again, it's kind of a confirmation of what you see in the app data, that the emotions and the stress level are here something important. When they have more grief, tinnitus goes up. When they have more frustration, when they're more stressed, and when they're nervous, then tinnitus is affected in a negative kind of way. But also, some people had less stress when sitting at lockdown, and for these people, the tinnitus was improved, or some were not so nervous, or were not frustrated, or did not have the feeling of grief. So this was something that we saw in the data, which was highly significant. We also looked at other variables and how they perceived it, but these were the 4 important things: the grief, frustration, stress, and if they were nervous. So now it shows us that the picture can be very complicated when we look at many patients at the same time. So here I tried to visualize that with 5 different patients being in these different situations with more stress or more negative emotions or better positive emotions, and during weekdays and during days. So people can perceive these situations differently, and also the association between the stress, for instance, and tinnitus can be different. So that can lead to a very, very difficult pattern, like what I described here. And the question is, of course, now, what does this have? And does this have an influence on the measurements that we should do for the clinical trials? And I just want to show you here on one example, like one individual patient that we used in one of the app studies. Here, as you see on the left-hand side in the gray area, which was a baseline phase where there was just measurements, and then in the white area, a treatment started. And you see that in the beginning, in the baseline phase, of course, there was a fluctuation of tinnitus distress and tinnitus loudness, and then the treatment starts, still fluctuations, and then at some point, day 50 or 60, it starts, the fluctuations went bigger and with higher magnitude. So imagine you're having this patient in a treatment study, in a clinical trial, and in the beginning you have to do the questionnaires, and in the end you have to do the questionnaires. Then it really matters at what day and what time you give them these questionnaires, and that can be these 3 different lines in the beginning and at the end, and there you can easily see that it really does matter at what time you measure. It can be that you come to the result that the tinnitus improved during the treatment, or worsened, or stayed the same, depending on at which of these red lines you do the measurements. So I think that's something that's important to keep in mind, that the time of the measurement is something important. So maybe as an advice that I can give here is, it's really important that when you're doing the pre-treatment measurements on a Monday, then also try to do the post-treatment measurements on a Monday, and maybe in the same time frame. And if possible, in similar situations, it should be the same kind of stress level, emotional level, and so on, to get reliable data here. That can really have an influence. We were thinking also about, can we use these measurements that we do in the app to kind of estimate the results of the questionnaires? And that's a work that PhD student in Regensburg did, Milena Engelke, very nice work that she's doing here, and we were using an app that was part of the Unity app. Later you will hear by Dimitris more about the Unity project, I guess. And this was a pilot study. We used 18 patients here, and we did the standard tinnitus questionnaires before and after. That's what you see on the left-hand side. We see a statistically significant difference and improvement of the THI, and we have the questionnaire app data here on the lower part of the slide, where you see the fluctuations of the tinnitus distress and tinnitus loudness. Now the question is, do these different measurements have something to do with each other? And how to analyze these app measurements, because there we have many measuring points, and for the questionnaires we just have 2, one before and one after. So what Milena did, she was calculating over the app data a trend line for the tinnitus loudness and for the tinnitus distress, and correlated this with a THI difference, and also she was taking in the beginning a time frame where she calculated the average, and at the end of the recordings, like in the last week, calculated an average, and calculated the difference between before and after time period. And there you see strong correlations between the differences in the THI score and the measurements and the algorithms that we used for analyzing the app measurements. Of course, that's just the first study here and the first work, and we have to work more on it, and also have to show it on a larger sample here. Remember, it's only an N of 18, but I think it already gives us the hint that there is a relationship. We can kind of trust the app data here, that they have to do something, have something to do with the questionnaires that we are using in standard clinical trials, that where we do the measurements before and after the questionnaire. So maybe that's something that where we can develop in the future to also include the app measurements here, where we can also then see when there are very high fluctuations because of whatever happened in the life of the patient. That gives us a hint here that maybe there's something more to look on. Then very quickly, because we're already running out of time, then another idea that I want to mention here, that is the work of Jorge Simoes, who's now in 20 at the university, and he looked also at the app data. Here I have 4 example patients. When you in the left column, you see the distribution of the different variables that we asked in the app. So we asked about the emotional arousal, about the valence, about the loudness of the tinnitus, the distress of the tinnitus, the concentration level and stress. And you see how it's distributed. In the middle column, you see the time development. And on the right column, you see correlations between the different variables. And what you can do then is to predict the tinnitus loudness by all these other variables. And because it's time series data, you can also use previous data points to predict the current tinnitus. So as an example, you can use the emotional valence and the stress level from yesterday to predict the tinnitus loudness today. And on the right-hand side on this plot, you see all these factors and how they influence the tinnitus loudness in the different patients that participated here. And you see how these variables are distributed. And what we can do then is to use these also to create some further plots for what I call the tinnitus fingerprint. So for each individual, we can look at how are the variables connected to each other. In the upper left-hand side, you see one figure where, for instance, there's a red line going from stress to loudness. Red lines mean positive influence, and blue lines are negative influence. And the solid lines are the connections of the within this moment measurement, and the dashed lines are that the factor from yesterday influences the current like time lag of -1. So what you say can create here is really a plot about what are the influencing factors of today and of yesterday on the tinnitus loudness. And you see that these are different for the different tinnitus individuals. And for some patients, for instance, there's a line from stress to tinnitus loudness, and for some others not. So maybe that could be an indicator for these people. It's important to teach them some stress management, and for some other patients maybe it's not needed because they are already good and there's no connection between the stress and the loudness. So I think this tinnitus fingerprints, or this digital phenotyping that we can do now with the app data, that is something that really can guide us for individual treatments in the future. We're coming to the end of my talk. I want to thank the group, the Unity group, the big European project, where we are almost finished now and analyzing the data, and many of the data that I showed is coming out of this Unity project here, and the eHealth group in Regensburg, and I want to thank you for your attention.